All right, so now that I've placed my special 30-degree triangle on my unit circle, I'm going to do the same thing with a 45, 45, 90. And so what I've done here is I've labeled the 45-degree increments, and I'm doing it in another color. And I'd like to see that going from the center, again, to the edge also has an increment of 1. And so when I drop down my perpendicular line here, this central angle right here now is 45 degrees. So again, the central angle being 45 degrees means this arc is also 45 degrees. And that's the same as a pi over 4 increment. And when we looked at special triangles with a hypotenuse of 1, and we set this equal to x root 2, that means that the length of this x value is root 2 over 2. And the other leg is the same. And so in special triangles, the legs have the same length. So this coordinate right here is the same as root 2 over 2 and root 2 over 2. Right? And so that's, again, the length of the x leg and the y leg to get to that coordinate. And now, again, if I do the same thing and I flip these special triangles to the other sides around my circle, I'm going to see that the same thing is going to happen as it did with the 30, 60, 90. All right? The length of these x and y legs are going to be the same measurement, just flipped into a different quadrant. Okay? And so when I flip this into a different quadrant, again, the x value is now going to be negative, but the y value stays positive. So in terms of flipping this, again, this side becomes a negative down the negative side of the x-axis, but positive along the y-axis. And so again, if I start thinking about increments, 45 times 2 times 3, this is the same as 135 degrees. No, not 1350. 135 degrees, or 3 pi over 4. Okay. When I flip the triangle down this way, both my x and my y coordinate are going to be negative. So I'm going to keep the same coordinate, but change them both to negative values. And again, that makes this a 225 degrees. So 225 degrees, which is also 5 of the pi over 4 increments. And then moving down to this area gives me an x value that's positive, but a y value that's negative. Okay, so again, we're doing the same process as we did with the 30, 60, 90, but we're going a little faster now that we can see the pattern. All right, so x values are positive here, y values are negative, so x value is positive, y values are negative from our reference triangle. And this is the same as 315 degrees, or 7 of the pi over 4 increments. Okay. Now, with the last of the special triangles, it's the 60-degree marks, which is the same as your 30-degree, but the lengths of the sides flip-flop. All right, so the lengths of the legs are still either 1/2 or root 3 over 2, depending on what side you're on. So I know I'm using a little bit of a darker marker here, but it's the only one I have in a different color for the moment. All right. And so what we're going to do is we're going to look at this triangle. And again, if I drop a little perpendicular line down this way, that makes this mark right here 60. So this is my 60-degree increment. And with 60-degree increments, the side that is opposite the 30 means that this length right here is now shorter. You can see that here 1/2 was the shortest leg, and the root 3 over 2 is the longest leg. Well, now that flips. Now this little distance right here is the 1/2, and the other leg is root 3 over 2. So the coordinate for the 60 is the same kind of coordinate, but flip-flopped, meaning that Now the x values are shorter and the y values are longer. And that's kind of hard to see, so I'm going to change my pen. Still use black, but I'm going to change my pen. That's a little tough to read. So that's the 1/2 root 3 over 2 coordinate. And this is also a pi over 6 increment. Right? And so we're going to flip that triangle around to get the remaining coordinates. And so again, when I flip that over this way, that means that I have a coordinate that is negative 1/2 root 3 over 2. And my increment is 120 degrees, or 2 of the pi over 3 increments. Right. Dropping down here, again, flipping the triangle upside down, right, means that if I'm looking at this coordinate, this is the coordinate that's going to move around all the way around the circle, just change value depending on the quadrant. So I'm just going to look up at this coordinate and write it with the correct signs. Right? Now again, because that's the 60-degree increment, then I'm going to have to add 60 to this, so this should be 240 degrees, or 4 of the pi over 3 increments. And then lastly, the coordinate is going to get flipped upside down. X value stays positive, y value stays negative, and this is the same as 300 degrees, or 5 of the pi over 3 increments. So now you're not going to be required to memorize this entire thing. What you will need to memorize are a few different key aspects, and that's going to be up here. We're going to consider this our reference quadrant. All right, so quadrant 1 is always the reference quadrant. All right. Whatever happens in this quadrant, if I can find a reference angle that is an increment of 30, 45, 60, or pi over 6, pi over 4. Oops, I said pi over 6 on this one, didn't I? That was silly. That was a pi over 3. My bad, I apologize. Or pi over 3. Then we're going to think about how those move around in the different quadrants and create the same coordinate but different values. And this is going to help us as we move into more trig.